Hello everybody, welcome back to another video with Amanj. In this video, we're going to talk about multiplying and dividing polynomials. Well, this is the second lesson of the second chapter in grade 10's book. So it's better to know this one because it is actually important for not only grade 10, grade 11, grade 12 as well. That's why you better take care of it, especially the dividing part and even the multiplying part as well. Both are important, but the dividing part, there is a small part of grade 12 regarding to the slant asymptote, that in that case you need to know long division of polynomials. Perfect. But let's not think about grade 12 for now and see how are we going to multiply and divide polynomials. All right. So in order to multiply and divide polynomials, the first of all, let's just deal with the multiplication. All right. For multiplying to multiply two polynomials expression, we should multiply each term of the first bracket by each term of the second bracket. What do we call this? Basically, there is a method, it's called FOIL method. So this is exactly the definition of that FOIL method, by the way, in a simple way. So imagine if there is an example like this, multiply these two polynomials. How are we going to multiply it? Based on this, that we wrote it over there. So x plus 2 times x minus 3. So here we wrote it that we should multiply each term of the first bracket by each term of the second bracket. So what do we have here? How many terms do we have? 2 terms here. So we should multiply each one of them by each term in the second bracket. So it means x times x, x times negative 3. Multiply each term of the first bracket by each term in the second bracket. And then multiply 2 by x and multiply by negative 3. This is exactly what we are going to see in the next slide, and it has a specific name, that way of multiplication. It is a method actually that called FOIL method. Perfect. So x times x, x times x, it's x squared. X times negative 3, x times negative 3, it's negative 3x. 2 times x, 2 times x, it's equal to 2x. And 2 times negative 3, 2 times negative 3, it's equal to negative 6. Perfect. So if you want to write the result perfectly, so we can say that, okay, it's equal to x squared minus 3x, 2x, they are like terms. So if you just operate them, it's going to become negative x, because negative 3, positive 2 together, they're going to become like negative 1. And x will stay the same because we are not going to change the variable when we add or subtract. And finally, minus 6. That is the result of this multiplication. We have got more examples, don't worry. So here, it's that method that actually I talked about it. Come back to that method. Yes. FOIL method. So it consists of 4 letters. FOIL. F stands for the very first multiplication, okay? X times x. The first term here and the first term here in both brackets. So when we multiply them, we call it the first multiplication. And then the first term multiply the last term in the second bracket. That is called outside multiplication. So that's O stands for outside. And then we have got these two terms that they are next to each other. They are the inner points. So we call them inside multiplication. And final multiplication, that it is called last multiplication. So the second term of the first bracket multiply by the second term of the second bracket. So it's called last multiplication. Perfect. So if you do it here, x times x, it's going to become x squared. X times 1, it's equal to x. It's written over there. 9 times x, 9x. And finally, 9 times 1, 9. Perfect. That is what FOIL method is telling us. So here we can use FOIL method for this type of question. Multiply these two polynomials. We have got two polynomials that we need to multiply them, all right? So the first multiplication is 2x times x. Then the outside multiplication is 2x times 4. The inside multiplication is 3 times x. And the last multiplication is 3 times 4. Let's just do them. So 2x times x, or it's better to say like first. You don't need to write this first and this kind of words in the exam. But in order to show you like how are we going to deal with FOIL method, this is the way. First multiplication is 2x times x. So it's going to become 2 times 1, 2, x times x, 2x squared. Okay, x1 and x2, x1, when we multiply them, keep the base, add the exponent. Perfect. And then the outside multiplication is 2x times 4. So 2 times 4, 8, and we write the x. Perfect. And then we have got inside multiplication. So the inside multiplication here, we have 3 times x. Well, it's going to become 3x. And then finally, the last multiplication is 3 times 4 is equal to 12. So if you want to write them as in a horizontal way, so the result would be in this way: 2x squared from like the highest exponent to the lowest exponent, that we call it general form, or sometimes it's called standard form. All right. So 2x squared plus 8x and 3x, since they are like terms, we can add them. So 8 plus 3, it's equal to 11x. And then finally, we have got plus 12. Perfect. I hope that it is clear and understandable, ladies and gentlemen. So the next slide, let's see what do we have. We have more examples or not. So here we are going to find out. Yes, definitely. We have got 3 beautiful examples that I am pretty sure that you guys are going to understand it after solving these 3 questions, like fully and completely. Okay, so I'm not going to write first, outside, inside, and this kind of stuff. So let's just do it normally without writing those words. So 3x times 2x, 3 times 2, perfect. 6x times x, x squared. 3x times 2, 3x times 2, it's equal to 6x. 1 times 2x, it's equal to 2x. And then finally, 1 times 2, it's equal to 2. So if you just want to operate them, in that case, it's going to become 6x squared. 6x plus 2x, it's equal to 8x. And then finally, we have got 2. That is the standard form of the result of the multiplication of these 2 polynomials. Look, 3 times 2, 6, x times x, x squared, 3x times 2, 6x, 1 times 2x, 2x, 2x and 6x together, they will make 8x. And then finally, 1 times 2, 2. How about the next one? Let's just change the color. Okay, so here, 4x times 3, perfect, 12x. 4x times negative x, 4 times negative 1, negative 4, x times x, x squared. Negative 2 times 3, it's equal to negative 6. Negative 2 times negative x, negative times negative, positive, 2 times x, 2x. So, let's arrange the terms from the highest exponent to the lowest one. So, we can say negative 4x squared because it has the highest exponent. And then we have 12x and positive 2x. So together, we are going to add them and they will make 14x. And then we have negative 6, which is minus 6. So this is the result of that multiplication. And then finally, we have got a beautiful question, a beautiful example. And it's actually interesting, this one. So let's just do it here. Okay. So x squared times 3x squared, the coefficient, first of all, the coefficient, 1 times 3, 3. X squared times x squared, x4. Perfect. So x squared times x, it's equal to, their coefficient, both of them are 1. 1 times 1, 1. X squared times x, well, it's going to make x3. Because, look, 2 and 1. When you multiply them, add the exponent. So x cubed plus 2x times 3x squared. So 2 times 3 is 6. x1 and x2, we're going to make x3. 2x times x, 2 times 1, 2. X times x, x2. Okay? Perfect. So the highest exponent is this term, 3x4. And here we have got some like terms. 1x cubed plus 6x cubed. It's going to make 7x cubed plus 2x squared. Be careful, guys. X squared times x squared, it's going to make x4. x2 times x1, it's going to make x3. x1 again times x2 will make x cubed again. x1 times x1, so it's going to make x2. In multiplication of powers with the same base, keep the base, add the exponent. Don't forget this. And that is the result of these 3 questions. I hope that you take a picture from it. Okay. Then what do we have? Okay, multiplying 2 polynomials. So a polynomial in general form is written as that. So simply this is like what we said already, what we mentioned, from the highest exponent to the lowest exponent. So where the terms are arranged in descending order of their exponent. Descending means from like highest to lowest, it's decreasing. There is something here, a question, right? The given polynomial in general form. So we need to multiply these 3 polynomials. One of them is x squared, the other one is x plus 1, the other one is x minus 1. This question has multiple ways to solve it, all right? But I'm going to just mention the easiest one. All right. Remember in grade 9 and even in 8, grade 9 actually especially, you study something like a special identity in this way, a minus b times a plus b. So in that case you said, remember, that the first term it's equal to the first term square minus the second term square. By the way, we are going to study this one again in the next section. Perfect. So a minus b, a plus b. So we are going to use that idea for this part. X plus 1, x minus 1. Look, 2 bracket. First term and second term are the same. There is the only difference between them is this plus and that minus. So in that case, we are going to use that idea. So we write x squared times, here, use that idea. First term is x, so x squared, minus the second term, 1 squared, it's equal to 1. So right now, this is a simple multiplication. X squared times x squared, it's going to give us x4. X squared times 1 minus x squared, that's it. So it's kind of like written already in general form from descending exponents. So like 4 is definitely bigger than 2, so it's already in general form. x4 minus x2 is the result of that multiplication. Perfect. Next thing, what do we have? Let's see. Okay. Here we have got some special identities. This is exactly what we discussed about it right now. What I mean by, I actually said next section, or next slide, not next section. All right, so the first item we have got 4 special identities like square of, difference, and sum. This is like the names of them. That is the difference between 2 squares. This is the difference between 2 cubes, and that is the sum between 2 cubed numbers. All right. So in order to deal with them, I already in class we discussed about them a lot. So let's just shortly tell you like how do we deal with them. If we have square of like sum or difference, like square of a bracket, we are going to say that in this way we will move on. First term square plus or minus, it depends on this sign. 2 times first term times the second term. 2 times a times b plus the second term square. All right. For this one, right before some minutes we mentioned it. So a squared minus b squared, if you want to just factorize it, it's equal to a minus b, a plus b. So in the exam, either the first the left side is given and ask for the right side, or the right side is given or ask you to and then ask you to get the left side. For the cube one, these two are new for you because you study already these two in previous grade, but this year you will study the difference and sum between two cubes. So always listen carefully. Always when we have sum and difference of two cube numbers, directly open two brackets, one small bracket and one big bracket. All right. In the small one, you are going to write the basis without the exponent. The basis without the exponent. As you can see here, we wrote only a minus b without the exponents. Then we are going to work on this one. So you will say that first term square. First term square. So here, first term is a square. Here is the point that it is very, very important, and unfortunately most of the students will make mistake in it. If here there is minus, so here the second term would be with plus. If here is plus, so here the second term would be with minus. So they are opposite. Okay, I will repeat it. If here there is minus, so the second term would be with plus. If here there is plus, so the second term would be with minus. Perfect. So we said that first term square, it's minus, so it's going to become plus. The second term is first term multiplied by the second term. So a times b, ab, and then finally the second term square. So let's solve some questions in order to make them clear. The first example is regarding to this identity, square of the difference. So we said that the first term square, x squared. Here is minus, so here is going to be minus. 2 times the first term, 2x, times the second term, 6x. And then plus the second term square, 9. 3 squared, 9. How about here? So you must know that it's x squared minus, what is the square of, 25 is the perfect square of what number? It's equal to, it's the perfect square of 5. 5 squared, it's equal to 25. Perfect. So right now, as you can see, we have difference between two squares. Difference between two squares. Immediately open two brackets, one with minus, one with plus. So x squared, 1x for here, 1x for here. 5 squared, 1 5 for here, 1 5 for here. That's it. Okay? So the next one is interesting. 27. So we must know that x3, we cannot do anything with it, minus 27 is a perfect cube of a number. What is that number? It's 3 powered by 3. So it's exactly in this form. Right now, we said that if we have sum or difference of two cubes, immediately open two brackets, one small and one big. So in the smaller one, you're going to write the basis without the exponent. So x minus 3. Then we said that we will go in this way. Listen carefully. First term square, so x squared. If there is minus here, we will have plus here. 3 times x, 3 times x. Plus the second term square, 3 squared, 9. That is how we are going to deal with difference of two cubes. Okay, how about sum of two cubes? Well, again, you need to be careful. x3, you might ask me, teacher, what is 125? It's not a cube number. Actually, it is. It is the perfect cubes of 5. 5 powered by 3. As you can see, so 5 powered by 3 means 5 times 5 times 5. It's going to give you 125. Perfect. So we said that when we have sum of two cubes, open two brackets, like one small, one big. So in the smaller one, you are going to write x plus 5 without their exponents. Then we will work on this one. We will say that, okay, first term square, so x squared. If there is plus here, so we will have minus here. Then multiply these two terms by each other. 5 times x, 5x. And then plus the second term square, 5 squared. I'm pretty sure everybody knows it, 25. This is how we are going to deal with factorization of some polynomials by using the special identities. Okay, Let's see what we have in the next slide. I'm pretty sure we have questions. Yes. So questions here, x squared, again it says factor these polynomials, so we need to factorize them by using the special identity. I said either the left side is given or the right side. As you can see here, x squared minus 8x plus 16. So you must know that it can be written as x squared minus 8x plus 16 is like square of 4. So since it has 3 terms, so it should be square of a difference. Perfect. How are we going to find here? So since there is minus in the second term, inside our bracket we have got minus. So x squared, 1x would come for here, and then 4 squared, so 1 4 for here. That is how we are going to factorize that polynomial. Okay? Okay, so how about the next one? It's easy. It's the difference between two squares, like it's equal to x squared minus 5 squared. So open two brackets, one with minus, one with plus. 1x for here, 1 5 for here, 1x for here, 1 5 for here. This is how you are going to factorize it by using the special identities. Perfect. In the next one, again, we have got 3 terms. So it is squares of difference or sum. So here, since there was minus, so it was square of difference. But here, since there is plus, so it's square of sum. So if you want to write this one in that way, so in that case, 2y will be, 4y squared, we can write it in this way, like 2y all square, in order to make a power form of it. So 2 powered by 2, 4, y powered by 2, y2. So instead of 4y squared, I'm going to write 2y powered by 2 plus 8y plus, instead of 4, I will write 2 powered by 2. So the power form of 4 is 2 powered by 2. Perfect. So right now, simply one factor of this 2y squared for here, so 2y, and one factor of these 2 would be for here. This is how you are going to factorize it. Perfect. And if you right now, if you open this one, you will definitely get this. Okay. How about the next one? It's the it is the difference between 2 cubes. So let's just bring it here. Okay. So y3 minus 64. So instead of 64, I will write 4 powered by 3. You can go and check it, because that is going to be helpful, and it's in the form, okay, form of like difference between 2 cubes. In that case, what was the method? What was the way? We said that we are going to open 2 brackets, one small, one big. In the smaller one, we will write the basis without the exponent, y minus 3, and in the bigger one, we are going to work on this one. Okay, so the first term square, y squared, there is minus here, so it's going to become plus here in the bigger one. Then multiply these 2 terms, 3 times y, 3y, and then finally 3 squared is equal to 9. Okay. Oh, by the way, sorry. It's 4. So I want you to just change these 2 terms. 4 times y, it's going to become 4y, and 4 squared, it's going to become 16. I just told myself, okay, 3 times 9 is 27. But actually, it was wrong. So 4 times 16 definitely will give us 64. Okay, the last one, it's the sum between 2 cubed numbers. So let's just come here and write it as sum of 2 cubes. So a powered by 3 plus 8 is the perfect cube of what number? Perfect, 2. 2 powered by 3. So in such a cases, what was the way? 2 brackets, one small, one big. In the smaller one, write the basis without the exponent, so a plus 2. So first term square, a squared. If there is plus here, so it would be minus second term. So 2 times a, 2a, and then finally plus 2 powered by 2, 4. So 4 times 2 definitely will give us 8. Okay. This is how we are going to factorize by using the special identities. Okay, but only just take care of this kind of cases if there are like three terms. When we want to factorize it, we should write the first term and the second term as perfect square, in perfect square form, in order to find out the terms inside the bracket that we are going to find it out. Okay. For example, just let me give you one example by myself. So if we have, let's say, 25a square minus, okay, if we have, let's say, 36 here, so 5a, let's say 30a here. Okay, if you have something like this, and the question is factorize it, so in that case, we need to write the first term and the last term, which is the third term, in perfect square form. So here, instead of 25a square, I can write 5a all powered by 2. 5a all powered by 2, because 5 squared, 25, a squared, a squared. So instead of 25a squared, I will write 5a squared. Why? Right now you will find it out. Minus 30a plus, instead of 36, I will write 6 squared. Whenever we have three terms and the question is factorize it, be 100% sure that it is the square of either sum or difference. How are we going to find out whether it is sum or difference? Based on this sign. If it is minus, sign of the second term. If there is minus, so it would be square of difference. So here, the purpose of turning this 25a squared to this way is like finding out the first term and the second term inside this bracket. So right now we can definitely find out and see it that the first term is 5a and the second term is 6. This is what I mean by rearranging this one into the perfect square form. Then we have got factoring polynomials. Again, we have three interesting questions. x3 plus 1. So you better know that it's 1 powered by 3, which is the sum of 2 cubed. So open 2 bracket. Here, x plus 1 without the exponent. So first term square, x square. There is plus here, so it will be minus with minus. X times 1, x. And 1 square, it's equal to 1. How about this one? This is a very, very important question that I remember one student asked me, teacher, is it only like minus between two squares? Can it be plus? If there is plus between two squares, guys, be careful. If there is plus between two squares, in that case, we are going to say that we have no solution. We cannot factorize it. Okay? Why? Because if you want to find the solution of this one, so equalize it to 0, move 4 to the other side. So in that case, it would be x squared equals to negative 4. The answer of square is always with positive, is always positive or 0. Okay? It's either 0 or positive. It can't be negative. Since it is negative here, so we are going to say that between two squares, there shouldn't be plus. Because in that case, if there is plus, we have no solution for it and we cannot factorize it. That is the story of this case. So factorize it. We cannot factorize it. We cannot factorize it. We cannot factorize it. And then we will find out in the next upcoming sections, if the question asks you to solve it, you are going to say no solution, or there is no solution for that question, for that quadratic function. How about here? We have three terms. So we need to write the first term and this, okay, it's equal to square of sum or difference. Okay, square of sum or difference. All right. Here, first term and the last term must be in perfect square form, like power form. So here the first one is, but the last one is not. So let's just make it 4x. Instead of this negative must be positive. You can just change it to. So 4, we can write it as 2 powered by 2. Okay. So right now, we can definitely find out, since there is minus here, so we have square of difference. The first term is what? X squared. So the first term here would be x. Here the last term is 2 powered by 2, so 1, 2 is going to come here. So this is going to be the factorization of that quadratic function. I hope that this lesson is clear so far. So let's see what we have in the upcoming slide. We have dividing two polynomials, okay? In dividing two polynomials, as we already mentioned, division is the inverse of multiplication, and it can be written in two ways. I don't know what is going on here. So it can be written in two ways. How two ways? Imagine we have got this. That polynomial, x cubed plus 3x2 plus 5x plus 6. So these are the two factors that we have it for that polynomials. These are two factors that we have it for that polynomial. So what I mean by, like, in division, when we divide a polynomial by another polynomial, when we do it, we can it can be written in two ways when we divide. When you divide that polynomial by here, the result would be x minus 3, as you can see here. The polynomial, the first one from the left side, divided by any of them would give you the other one. That's why division can be written in two ways. Division of two polynomials. Okay. And here, as you can see, that polynomial divided by this one will give you this. So inshallah, during the questions you are going to see it and clarify it and understand it better. But you better know that when we divide polynomials, it can be written in two ways. Okay. Let's say we use long division when the degree of the numerator is at least 1 greater than the degree of the denominator. So when we are going to use long division, because in order to divide polynomials, we need to use long division that you studied in previous grade, but you studied it for numbers, numerical example. But in this lesson, we are going to study it for the polynomials. How are we going to divide a polynomial by another polynomial? So for that reason, we will use long division. Let me just check the video whether it goes all going well or not. Yes. So long division structure is here. Dividend times divisor. Here is the quotient and here is the remainder. Okay. So this is the structure of the long division. I'm not going to ask you what is dividend, what is divisor, or what is the remainder. No. So you better know that if the degree of numerator is at least 1 greater than the degree of the denominator, we can use long division. So let's see what we have. The next upcoming slide. Okay, the steps of long division. Write the polynomial in general form. We need to write it in general form always. Okay. Divide the first dividend term by the first divisor term. So the first dividend was here. The first term of the dividend divided by the first term of the divisor. For example, here 2x3. 2x3 divided by x. That x will cancel 1x from here. So what will remain? 2x2. Or you can see 2 divided by 1, 2. x3 divided by x1. In division, we will subtract the exponent. So 3 minus 1, 2. Perfect. So as you can see, 2x2. Then it says multiply the quotient by the divisor to subtract from the dividend. Okay. So multiply this quotient that we got by the divisor to see what will happen. So 2 times 1, 2. x2 times x1, x3. And again, 2x2 times negative 3. Well, we are going to have negative, look. The divisor here is x minus 3. Be careful. So here it's equal to 2x2 times x, 2x3, 2x2 times negative 3, negative 6x squared. How? 2 times negative 3, negative 6x2. Right now, you know that in division we need to subtract it. So 2x cubed minus 2x cubed, it's going to become 0. You don't need to write it down even. So negative 5x2 minus 6x2. So these two negative is going to become positive. Positive 6x squared. So negative 5x squared plus 6x squared, it's going to give us only 1x squared. As you can see here, only 1x squared minus, bring out like one term, like 1 by 1. So bring down negative 8x next to x squared. Right now, again, the same process. Repeat step 1, 2, and 3 in the result of the subtraction. So let's just repeat it. We said that first term of the dividend, so first term here is x squared divided by the first term of the divisor. So x squared divided by x squared divided by x, rewrite x, 2 minus 1, 1. So it's x, only x, as you can see here. So multiply that quotient that you got by the divisor and then subtract it. So x times x, x squared, x times negative 3, negative 3x. So right now, again, I'm going to repeat it. In division, we are going to subtract. So x squared minus x squared, 0. You don't need to write it down. Negative 8x minus 3x. So again, this negative times this negative would become plus. So negative 8x plus 3x will give us negative 5x. As you can see here, negative 5x. Bring down the last term, which is 15. So right now, repeat the steps. The first term of the dividend, which is negative 5x, divided by x, the first term of the divisor. So x will cancel x, only negative 5 will remain. Only negative 5 will remain. So negative 5 times the divisor. Negative 5 times x, negative 5x, negative 5 times negative 3, positive 15. Perfect. So then subtract them. Negative 5x minus 5x, that's going to become plus. These two cancel each other. 15 minus 15, 0. So the remainder would become 0. This is how you are going to divide a polynomial by another polynomial by using long division. I'm pretty sure we have got examples here. Let's see. Dividing two polynomials. Yes. So x3, isn't it the previous example? Let me just check it. It's actually divided by x minus 3. So let's do it here. Perfect. So our dividend is x3 plus x2 minus 5x. Just write it here. X cubed plus x2 minus 5x plus 3 divided by x minus 1. That is the structure of our long division. That is the dividend, here is the divisor. The first step was what? Divide the first term of the dividend by the first term of the divisor. So x3 divided by x, so 3 minus 1, it's x2. So write x2 here. Okay. Multiply that quotient that you got by the whole divisor and write it here, then subtract it. So x2 times x, give us x3 minus x2 times negative 1, negative x2. Perfect. So x3 minus x3, 0. You don't need to write it. x2 minus, these two minus will become plus. So x2 plus x2, 2x2. Bring down one term. So it's equal to negative 5x. Perfect. Right now, repeat those steps that we did it before. So the first term here is 2x squared divided by the first term of the divisor, which is x. 2 divided by 1, 2. x2 divided by x, only 1x will remain. So here write positive 2x. Then multiply by the divisor. 2 times 1, 2. x1 times x, x2. Positive times negative. Negative 2x times 1, 2x. Perfect. So right now minus them. 2x squared minus 2x squared 0. No need to write it. Minus 5x minus 2x. These two minus will become plus. So negative 5x. Negative 5x plus 2x. What will remain? Negative 3x. Then finally bring down the last term, which is 3. Right now, repeat the steps. Negative 3x divided by x. Negative 3x divided by x. X's are going to cancel each other. Only negative 3 will remain. So right now, multiply that negative 3 by the whole divisor. So negative 3 times x, negative 3x, negative 3 times negative 1, plus 3. So if we just subtract them, that one is going to kill this one. Because negative 3 minus minus, so it's going to become plus. Minus 3x plus, negative 3x plus 3x, 0. 3 minus 3, 0. So the remainder would become 0. But as a note, remainder is not necessary to become 0 always. Sometimes it becomes something like a consonant, let's say. Okay. Do we have any other example? See? Yes. We have got two examples. I will solve one of them in case if we have time. So x3, okay, x3 minus 2x2 minus x minus 28 divided by x minus 4. I will solve that one and I will leave this one as a homework in order to check or test yourself whether you learn it or not. So x3 divided by x, let's do it here. x3 divided by x, we're gonna get x2. So multiply that x2 by the divisor. x2 times x, x3. x2 times negative 4, negative 4, x2. Perfect. Subtract them. x3 minus x3 is 0. You don't need to write it. Negative 2x2 minus, these two minus will become plus. So right now, negative 2x2 plus 4x2, we will have only 2x2. Bring down one more term, so minus x. Right now, repeat the steps. So negative 2x2 divided by x, negative 2x2 divided by x, negative 2 divided by 1, negative 2. x2 divided by x, x. So negative 2x times x, negative 2x squared. Negative 2x times negative 4, it's going to become 4x. Negative 2 times x, negative 2x squared. Negative 2x times negative 4. So negative times negative plus 2 times 4, 8x. Okay. So right now subtract them. If you subtract them, these two cancel each other, it's going to become 0. Then negative x minus 8x, negative x minus 8x, it's going to give us negative 9x. So negative 9x. Bring down the last term, which is negative 28. So right now, repeat the steps. Negative 9x divided by x, negative 9x divided by x, what will remain? Only negative 9. So you are going to write negative 9 here. Negative 9 times x, I will write it here. So negative 9x. Negative 9 times negative 4, negative times negative, plus 9 times 4, 36. Okay. So negative 9x minus 9x, they will cancel each other, 0. Negative 28 minus 36 together, it's become like 8 and 6, 14, which is negative 64. Negative 28 minus minus 36, so it's going to be something like this. Negative 28 minus 36. Well, 20 and 30, 50, 6 and 8, 14, 14 and 50, negative 64. And as I said, Since it's a constant and not divisible by x minus 4, because the degree here is 1, the degree here is 0, so it's not divisible, you will stop here. You will say that, okay, the quotient is x squared minus 2x minus 9, and the remainder is negative 64. That is all about division of polynomials. So there is only one question left here. I hope that you solve it and then test yourself, check it, write the result in the comment. Be 100% sure I will check it for you. It was a pleasure to be with you in this lesson, and take care of yourself, study well. Thank you so much again for listening to me. See you in another video.